Hi everyone and welcome to Learn A-Level Biology for free with Miss Estrick. In this video I'm going to be going through how potometers can be used to measure the uptake of water as a way to measure the rate of transpiration. So I have got a whole video on transpiration, cohesion, tension, which I've just linked here so you can watch that first. So just a brief recap, what is transpiration? So that is when water vapour is evaporating out of open stomata, which are mainly found on the leaves. And we can see here that when that water vapour does evaporate out of the leaves, that will then draw up this continuous water column through the xylem of the plant, and you get this continuous flow of water from the soil where it's absorbed by osmosis and then up the xylem and out by transpiration. And there are four key factors which affect the rate of transpiration: temperature, humidity, air movement or wind, and light intensity. So in this session we're going through how you can actually measure the rate of uptake of water to be a representation of the rate of transpiration. So it's using this piece of equipment which is called a potometer, and what potometers measure is how much water a particular piece of plant is taking up in a period of time. Now the reason that it's measuring uptake of water rather than transpiration is because it's near impossible to measure the rate of transpiration, and that's because it's water vapour that is coming out because it's evaporation, so it's very difficult to measure that. So instead, because the amount of water that is taken up is almost the same as the amount of water which evaporates by transpiration, we take it to be that however much water was taken up is proportional to the rate of transpiration. So that's what it's measuring. The uses are, you could just use it to see the rate of transpiration for one particular plant and compare that to a different plant species, or it could be the same plant but looking at the effect of those four variables that we said have an impact, so light intensity, air movement, humidity and temperature. So looking at how it's set up. So the first thing is you need to get your sample of plant into the potometer, and you tend to just cut off a small section, which you can see in this diagram, from the main plant. And when you cut it, it has to be cut underwater. And the reason for that is the xylem has negative pressure, meaning it's constantly pulling up the water from lower down. So if you were to cut the plant in the air, it's going to be pulling air into the xylem, and that will then break the continuous column of water, and you won't have transpiration working, or at least it won't work very efficiently. So we cut it underwater to make sure only water is being drawn into the xylem. The next step is the potometer equipment all needs to be filled with water, and again this is done completely submerged in water, and that's to make sure all air bubbles are removed. We then get that leafy part of the plant is put into the potometer through a rubber seal, like a rubber bung, and all of the sections where there is a joint gets covered in petroleum jelly to make the equipment completely airtight, and that's to make sure no air bubbles can get in, which would prevent the flow of water, but also to make sure no water can leak out and therefore affect the accuracy of the measure of the uptake of water. The final thing in terms of the setup is one single bubble does have to deliberately be introduced. And the way that is introduced is at this end here. Now this capillary tube will be lifted out of the water probably for about 5-10 seconds and then placed back into the water. And that 5-10 second gap will be enough time for some air to be drawn in to create that one air bubble. And the point of that is when that air bubble reaches 0 on the scale on your capillary tube, you can then start your stop clock, and then you can see how far that air bubble travels in a certain period of time. So these measurements are used for you to see how much water is taken up, and the way you're getting that idea is you're looking at how far that air bubble moves. So this water is continuously moving towards the plant, because as that plant is transpiring, more water is drawn up into the plant. So to convert this into an estimate of transpiration, the rate the distance of that bubble has moved can be used to work out the volume of water. So you would need to know the volume of a cylinder to be able to work out the volume of water that has moved, and then you would divide that by the time it took for that water to travel. And you can reset the apparatus, and that is the purpose of this reservoir of water. And this tap is closed when you're doing the experiment, but if you open this tap, that allows water from this reservoir to move into the capillary tube, and it then pushes that air bubble, and you can leave it flowing so it pushes the air bubble all the way out or just back to the start, then close the tap and restart the experiment so you can get multiple repeats. So that's how you would use a potometer. Just to check the understanding then, I've got 4 exam questions which are quite common linked to the use of potometers. So we'll go through them one at a time. If you want to have a go at them first, just pause the video now, have a go at those 4 questions and then press play and continue at that point. So the first one was, explain why the apparatus must be set up and the plant chute must be cut underwater. So this is what I was saying, it's due to that cohesion tension theory, it creates a negative pressure in the xylem, so it's constantly pulling up the water. So if it was, so that should say was there, so if it was cut in the air, it would draw air into the xylem instead, and that would break that continuous water column and prevent transpiration. So instead you have to cut it underwater to make sure no air bubbles are introduced into the xylem. The next one, why must all the joints in the apparatus be covered in petroleum jelly? First thing is just pointing out petroleum jelly is waterproof. So by covering all of these joints in this waterproof substance, it makes sure that no air can be introduced into the apparatus, but also makes sure that no water can leak out, which would impact your accuracy of your estimate of water taken up. So the common maths question is to work out the volume of water taken up to represent transpiration. And to work that out, because it's a rate, you need to know the volume of water that has been taken up by the plant. And that would be divided by the time it took for that quantity of water to be taken up. So here are the figures that we're given in this example. The air bubble has moved 15.28 millimetres in 1 minute. So they left it for 1 minute and that air bubble has moved 15.28 millimetres along that scale. The next piece of information is the radius of that capillary tube is 0.5 millimetres. So using that information we can work out the volume, and because it's a rate it'd be the volume divided by time taken. It was only 1 minute, so it will only be divided by 1. So essentially, we just need to work out the volume. So to work out the volume of a cylinder, it's pi r squared times L, which is the length or the distance that the air bubble moved. Now we're just going to assume that pi is 3.142 in this example. So we can then put in the data. So we've got pi, 0.5 squared, and the length or the distance was 15.28. Multiply all of those and it comes to 12. So that's 12 millimetres per minute. Sometimes you might be asked to do a conversion. They might ask you to convert that to a different unit. So maybe centimetres instead of millimetres. And per minute, perhaps they might ask you to convert it to seconds or hours. So the last question is, what variables would have to be controlled if you were to perform this experiment on 2 different plant species? So you're examining, is there a difference between the rate of transpiration on those 2 different plant species? And the key variable that has to be controlled is the surface area of the leaves. So you need to make sure there's the same number and the same size leaves so that's a fair comparison. And that is it for the potometer measuring the rate of transpiration. If you found it helpful, please give it a thumbs up.